Hello.
Okay, we are only gonna do part of this lesson because I don't have time to get the whole thing in.
Perfect.
But, 7.4, evaluating logarithms and logarithmic functions. So you have, E, which is Euler's number, it's a special number in math. Log with a base of 10 is a special number in math, it's on your calculator as well. And natural log goes with Euler's number, that's the LN, that's on your calculator. Okay? When you write something in exponential form, or when we graph growth or decay, we've been graphing something that says y equals a b to the x power, correct? Okay? Logarithmic functions have the same terms that happen. If you have an equation of 2 squared equals 4, 2 cubed equals 8, you know what that is. That's easy math. But if I have 2 to some power equals 6, we've got to come up with a way to solve that. And we're going to use logarithmic functions to do so, okay? Because you can't do that math in your head. Okay. Now, when we are looking at logarithmic functions, it can be written one of two ways, this way or this way. If it's written this way, we read it like this: log base b of y equals x. Log base b of y equals x. When I say base b, that means that's the base of what I'm raising my power to, okay?
So that would be your 2 at the top.
So that would be my 2 at the top, yes.
Okay.
It would be this 2 right here, right?
Yes.
Okay? The x is my power. So this is your power. This is your base down here. And your y is your answer or your solution. So when I rearrange it, I can rearrange it like this: b to the x power equals y. Okay? Because remember, when we solve functions, we're always plugging in for x and getting stuff out for y. So that's why it makes sense to write it that way.
What's your y again?
Your solution or your answer. Okay? These are just examples. They're examples of how we can go back and forth. If I have log base 2 of 8 equals 3, I can write it as 2 to the third power equals 8. These can be switched back and forth. You have to be able to switch them back and forth. Because sometimes, if they're written this way, I can't solve it. And sometimes when it's written this way, I can't solve it. So if I can switch them back and forth, I can solve. This says log base 4 of 1 equals 0, which means 4 to the 0 power gives me 1.
Oh, I like this.
You like it?
Yeah.
Okay.
I understand it now. Sorry.
Here I have log base 12 of 12 equals 1, which means 12 to the first power equals 12. Here I have log of base 1/4 of 4 equals -1. So I have 1/4 to the -1 gives me 4. Which makes sense because you have to know your rules of exponents.
When you flip it,
it gives you 4 over 1. Okay? So now we're going to do 3 on our 4. How do I rewrite log base 3 of 81 equals 4 in exponential form?
3 to the 4th equals 81.
Yes, 3 to the 4th equals 81. Okay? How do you rewrite log base 7 of 7 equals 1?
7 to the 1st equals 7.
Okay? How do you write log base 14 of 1 equals 0?
14 to 0 equals 0.
Okay? And how do you write log base 1/2 of 32 equals -5?
1/2 to the negative power equals 32.
Okay, 1/2 to the -5 equals 32.
So you don't even have to do it, you just have to take the.
Not right now, we don't have to.
Yeah.
Okay? So that's when they give us all the information, they want us to change them back and forth between logarithmic form and exponential form. Now we're going to look at some where we evaluate. When we evaluate, what does that mean? Yeah, you're going to get an answer, okay? So if I want to evaluate this, do you see how these do not have anything equal to them?
Yes.
Okay, that's when I'm going to evaluate. So how would I rewrite this so that I know I need to evaluate it?
4 to the x equals 64.
Yes, 4 to the x, because I don't know what it is, equals 64. Okay, what to the 4 to what power gives me 64?
No.
3.
Cubed. So your answer is 3. Okay? How do you do this one? How would I rewrite log base 5 of 0.2?
5 to x equals 0.2.
Okay, now this is where you have to think. If I went from a whole number to a fraction, what does my top have to be? Negative, yes, negative. Because it's going to have to flip it into a fraction. Let's just try and see what is 1/5 fraction-wise. Do you know what that is decimal-wise? It's 0.2. So it should be x to the what then? Or which? Yeah, it should be -1, right? X should equal -1. Because if I plug -1 in here, that means I get 1/5, which is equal to 0.2. Okay? So when it's fraction ones, you might have to think a little bit more, because you might have to see what that decimal is fraction. Okay? How do I change 1/5, log base 1/5 of 125?
1/5 to x equals 125.
Okay, now think about this one again too. You went from a fraction to a whole number, so what type of exponent do you have to have? Negative. And 5 to what power gives you 125?
No.
5 cubed gives you 125, right?
Yes.
So it's going to be
Negative.
-3.
I don't know why I said
Okay? Do you see how I'm asking these questions, like how it works? Now, how do I set up log base 36 of 6?
36 to x equals 6.
Okay, do you see how this one is going from a large number to a small number?
Yes.
Okay, so here's how I work it in my brain. I say, how do I get 6 to 36? What do you do?
Multiply. Divide. No.
You square it, right? So if I have to square 6 to get to 36, what am I going to have to do to 36 to break it down to 6?
No.
What'd you say? Yeah, you'd have to take the square root, okay? How do I represent that in exponent form? 1/2,
Okay.
okay? So that's when you're going to get exponents that are fractions, or when you're going from larger numbers to smaller numbers, okay? So in this case, it would be 1/2, because if I raise 36 to 1/2, that means I'm taking the square root of 36, which will give me 6, okay? Large numbers to smaller numbers, I have to have a fraction, because I'm taking a root of something, okay? If I go from a fraction to a whole number, I am multiplying by a negative probably. And if I'm going from a whole number to a fraction, I'm multiplying by a negative most likely, okay?
Okay, this is easy. You should just leave it here.
Okay. Then we get things, that we've been working with, but natural log and common log, okay? There are 2 logs, we've talked about both of these a little bit. Common logarithm is a logarithm with a base of 10. So on your calculator, when you press log, it automatically has a base of 10, even though it does not show it. A lot of times it's gonna look like this. And then you'll just plug in your whole number or whatever it is you have here. That is a base of 10, okay? If it doesn't have it, it's a base of 10. It would specify if the base is different. But log base 10 of x equals log x. It's the same thing, okay? Log base e of x is the same as putting in natural log, okay? This natural log right here has a base of e, okay? They just get rid of it because it's how we use it on our calculator. It's just simpler, okay?
Oh, so that's when we push second.
Yes.
And then ln. Okay.
Yes. Okay, so if I want to just come up with solutions of these or evaluate these, how would you evaluate what log 8 is? What do you get on your calculator?
0.9.
0.9. So it's congruent to 0.9. What about when you're doing the natural log of 0.3? Negative 1.2. Okay, can you handle doing that on your homework?
Log, log's above.
Yes, it's above natural.
Log right now.
Oh, LN is natural.
Natural log, and the log button is called common log. So common and natural.
We're using both.
Yes.
We got it.
Okay, then you get word problems, and usually you hate word problems, but this is the easiest word problem of your life. The wind speed, S in miles per hour, near the center of a tornado can be modeled by S equals 93 log D plus 65. D is the distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states. Estimate the wind speed near the tornado center. How do I do that?
So you have 1 and 220.
To what?
D,
For D.
and then just solve it.
Yes. And so since they came up and told us that it's a logarithmic function, I can solve this very easy. Now, listen, when you plug this into your calculator, okay, you can do it one of 2 ways, okay? You can do 93 and then do log parentheses 220 parentheses plus 65. Or you can figure out what log 220 is first, multiply it by 93, and then add it to 65. But you need to make sure that you have parentheses in there if you're doing it all in one unit, or it's not gonna read it right. Okay, what'd you get as your answer? 282.8,
Yes.
and this is in miles per hour, right? Miles per hour, okay? I think we have one more thing to do. Oh no, that's when we're stopping today. We'll talk about inverse functions tomorrow. Well, not tomorrow, I guess, Tuesday, right? Yes, yes. Your calculator's different, that's why.
No, use the graph.